Company has 1,825 employees and they're classified as professional, skilled, or elementary. And this table shows the number in each classification as well as the two areas where they live. An employee is chosen at random from all of them, find the probability that they are skilled. So that is going to be these two added together, which gives 365. Then we're going to divide by the total number. And lives in area B and is not a professional. That's going to be these two. So 170 over 1825. Now, some classifications of employees are more likely to work from home, and we're given a lot of information here, and we're asked to fill out the Venn diagram. So let's get to it. 65% of professional employees in both area A and B work from home. So we've got 740 from A, and we can find 65% of that, which is 481. Now we've just got to get our head around this Venn diagram. So H is employees that work from home, R is if they're from A, area A, and F is if they're professional. So in the very middle, they're working from home from area A and they're professional. So actually that 481 is going to go in the middle. So dealt with that. Let's look at area B. So then it's 380 times 0.65. 247. And that one's already in there because this is people who are working from home, professional, but not from area A. 5% of elementary employees in both area A and B work from home, and 40% of skills. So I should have said that one first. Okay, so let's find the number of people who are not professional. That's going to be they're either skilled or elementary, and they work from home. So we've got 40% of skilled. By the way, some of these might already be in a table, but I just figure let's just find them out because at least we can, check our process is working. So 40% of the 275, and then it was 5% of the 260. So this gives 123 that are not professional, but they work from home and they're from area A. Actually, we've already got that one on the table as well. Then where would it be if they are not professional, work from home, but are from area B? It means I think it's going to be this one because it's, yeah, not in area R, not professional, but work from home is that little bit left over. So, okay, we can figure that one out now. So it'd be 380, 90 times 0.4, and then 0.05 times 80. And this gives 40. Goes here. Dealt with this one as well. The one I've not yet got is this one here. So that is people who are professional. They live in area A, but they don't work from home. Now that is 35% of them. Or I think I'm just going to work it out from there. Like this, it's quite confusing. I got to say this Venn diagram, working out, what you're trying to calculate. You could do it other ways than I'm doing it, but I'm just going to stick with this approach. So 35% are in area, 35% of professional employees in area A do not work from home. So I can do 740 times 0.35. That gives me 259. So that is going to go here. And then to get the last one, there's one on the outside. So that is people who do not work from home, are not professional, and live in area B. I just did the full amount, 1825 minus all of them, which got me 130. But maybe it's best to just check and do it another way, because this is the very last one, so we'll know if we've done it right for sure. So let's just look at this again. It was area B, not professional, don't work from home. So that is 60% of these people and 95% of these people. So it would be zero point 0.6 times 90 plus 0.95 times 80. And if you work that out, it again gives you 130. So you can be pretty happy with your Venn diagram. I'd say definitely like spend time on that so that, I mean, you should get follow through marks for D, E, and F, to be fair. But it's good to make sure it's correct. Now we've got these probabilities. The probability of the intersection of not R and F. So not R is going to be everything that's not in R. So it's going to be these four, but it's also got to be an F. So it's going to be these two. So just add those two together. This gives 380. And I'm dividing by the total number, 1825. No need to simplify. That's absolutely fine. Then probability of the union of H and R, but then not that. So the union is going to be all of this. And if we do not, then we're going to be left with 133 and 130, which is 263. And finally, the probability of F given H. Now, there is a formula for this, but in this sort of Venn diagram scenario, there's a much easier way to do it. Given H, so we can basically just ignore these. We know it's going to be out of these people here. And then if it's also got to be in F, well, that's these people. So I can add them together. This gives 728 divided by the total number of people in H, which is 891. And that's our answer. So you could do the intersection of F and H probability divided by probability of H. You get exactly the same thing. It's just you'll end up dividing by 1825 like on the top and the bottom and then cancel it down. So, I've managed to avoid that just by using this other method, but it's up to you. As long as it makes sense, that's the main thing. All right, gotta say that. It's a bit tricky, the Venn diagram part. Just it's so easy, I think, to make a mistake. But this is why I checked that 130 by in two different ways, so I can be pretty confident that it was correct. Well done.